This problem is from GATE 2021 Mechanical Engineering of Set 1. The question is, let C represent the unit circle centered at origin in the complex plane and complex variable is z is equal to x plus iota y. The value of contour integral on path C cos hyperbolic 3z divided by 2z into dz, where integration is taken counterclockwise direction. So the counterclockwise direction means that integration is taken as positive. Now the four options are given here, among which we need to find the correct answer. Now to get more information on contour integral, such as the derivation of Cauchy integral theorem, you can follow the course on Cauchy integral theorem in Advanced Engineering Mathematics delivered by Professor P.D. Srivatsava and colleagues from the Department of Mathematics, IIT Kharagpur. Now suppose you have any random curve C on which the function is analytical. Analytics means that if this function f of z, it must have a derivative on this curve. Also, all the points inside the curve are analytic. Now suppose there is a point A inside this closed curve C. So the Cauchy integral theorem for this point A can be written as f of A is equal to 1 by 2 pi iota the closed integral of C on path C f of z divided by z minus A into dz. Now let this be equation number 1. Now in our problem, the value of C is given as a circle on the complex plane. So let's draw a complex plane with contour C. Now this is a complex plane with x as real axis and iota y as imaginary axis, and the closed curve C is given by this circle whose center is at this origin. And we need to find the value of integral, the closed integral over C cos hyperbolic of 3z divided by 2z into dz. Now this integral value we need to find out. Suppose there is a point A here, and here we don't know where this point A lies in the circle. You can pause the video and try to find the solution of this integral using this given informations. Moving ahead, we can write this integral as closed integral on path C cos hyperbolic 3z divided by 2 whole divided by z minus 0 into dz. Let this be equation number 2. Now by cross multiplying this 2 pi iota to the left hand side, we can write the equation number 1 as, so equation number 1 can be written as 2 pi iota f of A equal to closed integrals on path C f of z divided by z minus A into dz. Now let this be equation number 3. Now comparing equation number 2 with equation number 3, we get, so what we get here, f of z is equal to cos hyperbolic 3z divided by 2 and A is equal to 0. Since we got the value of A is equal to 0, we can say the pole of the given function is at z is equal to 0. So lies inside the circle. Now from here we can substitute cos hyperbolic value. So we can write f of z is equal to cos hyperbolic 3z can be written as e to the power of 3z plus e to the power of negative 3z divided by 2 whole divided by 2. Further, which can be simplified to e to the power of 3z plus e to the power of negative 3z whole divided by 4. Now to find f of 0, we can substitute z is equal to 0. So we will get, from here we can get f of 0. So substituting z is equal to 0 in this function, we will get f of 0 is equal to e to the power of 0 plus e to the power of 0 whole divided by 4. Now e to the power of 0 is 1. So this will be 1 plus 1, that is 2 divided by 4 or 1 by 2. So the value of f of 0 we got is 1 by 2. Now according to Cauchy integral formula, we already know that closed integral on path C f of z divided by z minus a into dz is given as 2 pi I f of a. Now we have already got the value of a is equal to 0 and f of z is equal to cos hyperbolic 3z by 2. So now we will substitute these two values here. We will get at a is equal to 0, the value of this integral will become closed integral on path C. F of z we have already got cos hyperbolic 3z divided by 2, and this whole divided by z minus a value is 0 into dz, and that is equal to 2 pi iota f of 0, because we are substituting a is equal to 0. Also we have calculated the value of f of 0, that is 1 by 2. So now let's substitute the value of f of 0 here. We will get, it will be 2 pi iota into f of 0 is 1 by 2. So 2 will get cancelled out and we will get pi iota. So in this way we have calculated the value of given integral, that is closed integral on contour C cos hyperbolic 3z divided by 2z into dz is equal to pi I. Now let's match this answer with our given options. So in the options you will see here, option C is the correct choice, that is pi iota. Hopefully I was able to clear your doubt. Have a great day. Thank you.